So yeah, let's talk about linearizations and linear approximations. And really, this is just kind of redoing or calling something we've already done in a little different manner. Because we've already really done this, but just point some things out. Yeah, if I have this function, f of x, and then I take the tangent line at some given x value. And let's think about the equation of the tangent line in point-slope form. I know I mainly work with y equals mx plus b form, but point-slope form, it's y minus y1 equals m times x minus x1. That's point-slope form. Okay? And actually, I want this value to be a, because that's the way the book will designate it. We did that before, but let's just call that x value we're doing the tangent line at the x value a. Switch that back to a there. Okay? So, here's in general. Now, what I can, as far as the equation of the tangent line goes, isn't this point that I've got the tangent line at, isn't that a f of a? Isn't that the point? That'd be the point. Okay, and so back on the point-slope form, that would be, this is my x1 and y1. So if I plug in that for x1 and that one for y1, I get, this would be y minus f of a equals, and then we'll talk about m just a second, x minus x1 would be x minus a. M being the slope, in calculus terms, what's the slope of that line? It's the derivative. And in this case, it'd be the derivative at a, right? So f prime at a. Okay? What the linearization, linear approximation does is solve this for y. We get, just add f of a here to both sides. And I think they usually put it here. So we get y equals, and let's put the f of a first, plus f prime of a times x minus a. Okay. Okay, so for various reasons, here's what we're going to do. We are going to call this now, this line, so this is, what is this? This is the equation of the tangent line of our function. That's the equation of the tangent line using a, the x value at a, the x value of a. We're going to call that the linearization of f at a. And we are going to, because that starts with L, we're going to call that L of x. L of x equals f of a plus f prime of a times x minus a. It's called the linearization. Why do we call it that? Well, it's because if you look, and you can do this for any function you want to, but if you look at this function and you look at this tangent line, you know, when you draw those in, there's only officially one point of tangent there. However, if you look at this function, if you zoom in right at that particular point of tangent, there's not a whole lot of difference. If you're real close, there's not a whole lot of difference between the function curve and that straight line. In other words, the tangent line around a closely resembles the function value at a. Even though f is a curved thing, around a, if we find that tangent line at a, around that point at x equals a, the tangent line approximates the actual function. No matter what shape or size, that's always true about the tangent line. So this, in other words, this approximates linearly anyway the function at A. Okay? And you'll see something really nice. So that line, that's just a line, a linear function, so it's just a line. That line approximates the function, even though the function may be something real curved, maybe not curved so much, but yeah, it approximates. So that's what we're talking about. Linearization, linear approximation, that's what we're doing here, okay? All right, so how does it work? Well, let's find a couple of linearizations. This L of x find the linearization L of x at for f of x equals x cubed minus 4x squared at a equals 3. I believe is the wording they will potentially use. And so it's really just a matter of knowing what they mean. L of x is that formula. It's f of a plus f prime of a times x minus a. So in this case, a is 3, so that'd be f of 3 plus f prime of 3 times x minus 3. Calculate those all, plug them in, and you got it, which just means, that's just the function value at 3. Plug in f. So f of 3 here would be what? 3 cubed minus 4 times 3 squared. So that's going to be 27 minus 36, isn't it? Negative 9. So that goes right there. F prime of 3, well, that's just the derivative. My derivative is 3x squared minus 8x. So f prime at 3, plug in the 3 there, be 3 times 3 squared would be 9, minus 8 times 3, that's 27 minus 24. Is that positive 3? With me on that? I do believe they'll simplify this out. Negative 9 plus distributor 3. So we get 3x minus 9, so that's 3x minus 18. Okay? That's the linearization at a equals 3. Now, also, you might note there, what is this? This is just a tangent line at 3. Okay, that's all it is. It's just a more direct route, if you will, to doing it, but we're calling it the linearization. Okay, so they'll have you do a couple of those. But here's another thing. They'll have you do what's called verifying a linearization. Let's verify that verify the linear approximation at a equals 0 sine of x is approximately equal to x. Now, what do they want us to do here? Well, what they're saying is, if my function is sine of x, so this is my function, the function is sine of x, then the linearization at 0, L of x is x. That's all they're saying. They're saying this function can be approximated by x, just that function, at a equals 0 anyway. So that's what they're saying. So I'm going to take f of x equals sine of x, and I'm going to get the L of x at a equals 0. That's what this, in so many terms anyway, is asking us to do. Okay. All right. Well, we know that L of x equals f of a plus f prime of a times x minus a. And this one's real nice because what is a? A is 0. Okay, so L of x equals f of 0 plus f prime of 0 times x minus 0. Just plug in the a to be 0. So if I can figure out what all those values work out to be, I got this. All right, well, f of 0 is easy. What is f of 0? F of 0 will be sine of 0. And we all know and love sine of 0, don't we? Because what's the sine of 0? 0. Okay. F of 0 is 0. So we've got L of x equals 0. Plus, now f prime, well, f prime would be cosine of x. And so f prime of 0 would be cosine of 0, which is, that's not too bad either. What's cosine of 0? Isn't that 1? Okay, f prime of 0 is 1. And this, well, x minus 0 is just x. Hey, look at that. What does that simplify out to be? 1x is x. There you go. Okay? Now, what you might note here is what this means. What this means is, like if I'm talking about at x is 0. So if I'm talking about sine of something close to 0, say 0.1, what this is saying is that's going to be approximately 0.1 without even having to punch it in your calculator. That's what that's saying. Sine of negative 0.005, that's going to be approximately negative 0.005. That's what that's saying. Is that close? Punch those in, see what you get. Sine of 0.1, 0.099, which is about 0.1, isn't it? Sine of negative 0.5, 0.005, sorry, is negative 0.0049. It works. Okay, that's what we're saying. Okay, that's what this is good for. So this is real good. Like if you have a bunch of these signs close to 0, yeah, you might as well just take that to be your answer. So it makes it nice on those.